Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone, welcome to AB Chemistry, General Chemistry Lecture 5. Let us continue in Chapter 1, Atomic Structure and Properties. Percentage composition of a compound in a mixture. The mass percent of a compound equal to the mass of the compound divided by the total mass of a mixture times 100. Let's have an example. A 1.6 gram tablet is found to contain 0.0133 mole of amino acid glycine with molecular formula C2H5NO2. The molar mass of glycine is 75.07 gram per mole. What is the mass percent of glycine in the tablet? Recall that number of moles equal to the mass divided by molar mass. Well, then the mass will be equal to number of moles times molecular mass. Mass of glycine will be equal to molar mass of glycine times the number of moles. Given 75 for molar mass, 0.07, and number of moles 0.0133, that gives mass of glycine 0.998 gram. So the mass percent will be the mass of glycine divided by the total mass of sample tablet times 100. The answer is 62.4%. A student determines that a 3 gram mixture of zinc oxide solid and silver oxide solid mixture contains 0.010 mole zinc oxide. Based on the student measurement, what is the mass percent of zinc in the mixture? The molar mass of zinc, 65.38 gram per mole. Well, number of moles given for zinc oxide 0.010 moles. From the formula, 1 mole of zinc oxide contains 1 mole of zinc and 1 mole of oxygen. So the number of moles of zinc will be 0.010 moles. As we mentioned before, mass of zinc will be the number of moles of zinc times the molar mass of zinc. Here we have 0.010 and given molar mass 65.38 gram per mole makes the mass of zinc in the mixture 0.654. Well, the mass percent of zinc will be the mass of zinc divided by the total mass of the mixture times 100. We have here this number 3 significant figure, we have here 2 significant figure, and the answer will be 2 significant figure according to the rule. So it's 22%. A 1.60 gram calcium supplement contains 37.8% calcium by mass. The calcium is present in the supplement as calcium carbonate solid. The molar mass of calcium carbonate 100.09 gram per mole. How many grams of calcium carbonates are in the calcium supplement? Well, mass percent of calcium will be equal to the mass of calcium divided by total mass of the samples 100 times 100. Well, given calcium percent 37.8, mass of calcium is unknown. The sample is 1.06 gram times 100, that makes X equal to 0.6059 gram. Well, number of moles of calcium will be 0.605 gram divided by molar mass of calcium which is 40.08. Okay, that gives the number of moles equal to 0.0151 mole. Each mole of calcium carbonate from the formula contains 1 mole. Each mole contains 1 mole of calcium. So the number of moles of calcium carbonate will be equal to the number of moles of calcium, 1.015 moles. The mass of calcium carbonate will be the number of moles times the molar mass, will be equal number of moles time given molar mass of calcium carbonate, makes the calcium carbonate 1.51 gram. Recall we have applied this principle earlier, percentage composition of compounds. Find the percent composition of the compound N2O5 where the atomic mass of nitrogen 14.01 atomic mass unit and for oxygen 16.00 atomic mass unit. From the formula N2O5, each 1 mole of N2O5 we have 2 moles nitrogen and 5 moles oxygen. So the total mass of 1 mole of N2O5 will be 2 times 14.01 plus 5 times 16.00. For the nitrogen, the mass will be 28.02, and for the oxygen, 80, total of 108.02 grams N2O5. To get the percentage of nitrogen will be the mass of nitrogen divided by the total mass times 100. That gives 25.94% nitrogen. Mass percent of oxygen will be 80 divided by 108, total mass 0.02 times 100 will give you 74.06 percentage of oxygen. Well, one compound of mercury with a molar mass of 519 contains 77.26% mercury, 9.25 carbon, 1.17 hydrogen, and the rest of the balance will be oxygen. Calculate empirical and molecular formula arranging the symbols in the order of mercury first, carbon, hydrogen, oxygen. Given atomic mass for mercury 200.59, carbon 12.01, hydrogen 1.01, and oxygen 16.00. Well, assume a 100 gram of the sample, then we have 77.26 gram mercury, 9.25 gram of carbon, 1.17 gram of hydrogen, and the rest of 100 will be 12.32. We put the relative mass ratio, okay, 77.26, 9.25, 1.17, and oxygen 12.32. So the ratio in mole, we divide the mass by molar mass. So it will be 77.26 divided by 200.59 gives you 0.3852. Carbon 9.25 divided by 12, it would be 0.770. Hydrogen 1.17, that makes divide by 1 makes 1.16, and the oxygen will divide this number on 16, gives you that. We divide by the lowest one, so this will be 1, this will be 2, this will be 3, and this will be 2. So the empirical formula will be HgC2H3O2. This is the empirical formula. What we have to do is calculate the mass from the empirical formula. So it will be 1 times 200.59, 2 times 12, 3 times 1.1, 2 times 16, total of 259.64 gram per mole. The ratio to the actual mass, so the mass, molar mass given to you, 519, divide by the mass of the molecular formula, give you the ratio 2. So all what we have to do, just multiply that by 2 twice, will give you the molecular formula Hg2C4H6O4. See you next lecture.